Final review number 3. Use your graphing calculator to make the parent function y equals the square root of x. Then graph the additional functions in the table and fill in the blank. Again, if you know what you're doing here, you don't have to use the calculator, but the calculator helps. Plug this into y1, then plug each of these into y2, and tell me what it does. Remember, -4 on the outside of the square root. This is a translation or a shift down 4. Inside does the opposite, so x -4 tells me I go right 4. Outside tells me I'm going to go down. Now this is a shift or a translation. Excuse me. Shift. I'm going to go down 3, and this is the opposite, so I'm going to go left 3, and that is a shift. The negative in front tells me that I want to do a reflection over the x-axis. 0.2 in front tells me I want a vertical. Since it's between 0 and 1, it's a vertical compression. 3 is greater than 1, so this is a vertical stretch. All right, let's talk about our domains and ranges. Unless I move it, the domain and range is going to stay the same. So on this first one, I'm changing my y since it went down. So y's are going to be greater than or equal to -4 since it went down. My x's I didn't touch, so they don't change. Here my x's change, so x is going to be greater than or equal to 4. My y doesn't change. Here I went down 3, so my x's stay the same, but I moved up and down, so my y is going to be, I went down 3, okay? So that's going to be greater than or equal to -3. Here I went left 3, so x is greater than or equal to -3, and y doesn't change. Left is x, up and down is y. Here, the reflection, the x stays the same, but the y, instead of being greater than or equal to 0, is less than or equal to 0. 0.2 vertical compression doesn't change my x's or my y's. Vertical stretch doesn't change my x's or my y's, and I can graph these on my graph if that's helpful to me. Let's go to number 2. Use the table to answer the following questions. Make a scatter plot of the data. Find a function that fits the data. So let's see, 0.5 is 2.26. 1.5 is 3.92, so just around 4. 2.5 is 5.06, so just above 5. 3.5 is just at 6. 4.5 is just below 7. 5.5 is about 7, is exactly 7.5. 6.5 is just a little more than 8. Now, I'm doing square roots. I want to do a square root function, so I bring up my calculator, and I want to do a square root of function. So I'm going to do the square root of x. Now I need to plug this into my calculator, so I hit stat 1. My L1s are 0.5, 1.5. I'm going to pause and enter this in, so you can go ahead and pause it, enter it into your calculator. Okay, so I have it in my calculator. I'm going to hit second y equals to turn my stat plot on. I'm going to do zoom. Well, here's my lovely little window. Here's a really nice window that I can use. It tells me what I want as a window. So go back to my calculator, plug in this window. 0 to 10 for my x's, count by ones. 0 to 10 for my y's, count by ones. Graph. Now those points is the scatter plot. That line, remember, was the y equals the square root of x. That is too small. So I'm going to hit second delete, and I'm going to stick in a number. Try 5. Hit graph. Too big. Okay, try 3. Just barely too small. Okay, I'm going to scoot over, hit second delete to insert again. I'm going to hit 0.5. Too big. Okay, let's try 0.3. Too big. Okay, so 3.3 was too big. Let's try 3.2. Ah, that's what I'm looking for. So my equation is y equals 3.2 square root x. So this is y is equal to 3.2 square root of x. There's my function. Inverses, inverses. Graph f of x equals the square root of x plus 4 using the table. Okay, remember how we did this. There was a couple ways of doing this. So like I said, there's a couple ways of doing this. The first way that we can do this is we can work this backwards. Remember, y is equal to the square root of x plus 4. Square roots have to be whole numbers. So there's lots of ways I can do this. The easiest way I have of doing this is to say, well, I want y to be nice numbers. I want y to be 0. I want y to be 1. I want y to be 2. I want y to be 3. Remember, these are square roots, so I can't have negative as answers for square roots, and that right away tells me that my domain is x is greater than or equal to, well, now again, I want this to be positive. I want this x plus 4 to be greater than or equal to 0. So if you subtract 4, I get x is greater than or equal to negative 4. So that's my domain. X is greater than or equal to negative 4. My range, well, my range is, there's nothing that changes. There's nothing added or subtracted out here. There's nothing that changes my range. So y is going to be greater than or equal to 0. And so then my domain and range for the inverse switches, x is going to be greater than or equal to 0. Y is going to be greater than or equal to negative 4. I needed to plot these points. So, okay, so I have this weird 0, 1, 2, 3. Well, again, I want y to be 0, so I want that to be the square root of x plus 4, where I'm going to square both sides. 0 is equal to the square and the square root cancel, x plus 4, subtract 4, so that I have x is equal to negative 4. So x is negative 4. So I have the coordinate negative 4, 0. Again, I'm working this backwards. I want my y, my f of x, to be 1. What does x need to be? Well, this is the square root of x plus 4. Again, you have to square both sides. 1 squared is 1. The square and the square root cancel, leaving x plus 4. Subtract 4 from both sides. You get negative 3 is equal to x. So this is negative 3. Again, I want to do this now for 2. I want 2 to equal the square root of x plus 4. I want to get rid of the square root, so I'm going to square both sides. The square and the square root cancel. 2 squared is 4. X plus 4 is equal to 4. Subtract 4 from both sides. X is equal to 0. So I get the coordinate 0, 2. So again, I had the coordinate negative 3, 1. And now I have the coordinate 0, 2. And lastly, I want my y to be 3. So this is going to be 3 is equal to the square root of x plus 4. I want to square both sides. This is 9. The square and the square root cancel. I get x plus 4. Subtract 4 from both sides. I get x is equal to 5. So this is the coordinate 1, 2, 3, 4, 5, 1, 2, 3. So there's my graph. If I want to graph the inverse, flip them around. Negative 4, 0 becomes 0, negative 4. Negative 3, 1 becomes 1, negative 3. 0, 2 becomes 2, 0. And 5, 3 becomes 3, 5. There's the graph of my inverse. All right. Now I need my function. Well, you need to realize the inverse function, you did the work for it in all this stuff already. So how does that work? Well, remember, this is y is equal to square root of x plus 4. To find the inverse, you switch x and y and solve for y. The first thing we did every time is we squared both things. The square and the square root cancel, so x squared is equal to y plus 4. We subtract 4 from both sides. X squared minus 4 is equal to y. That is my inverse function. I switch x and y and solve for y. So y is equal to x squared minus 4, or we can say f inverse of x is equal to x squared minus 4. All right, let's go to the back side. On the back, for each graph, answers the questions A through D. Sketch the domain and range of the function. My domain, my x's, again, this goes off forever in the right. This goes off forever to the left. So I know that x is an element of all real numbers. What about my range? My range, well, that's my y's. I'm never going to have a y down here. So it's going to be y's that are, greater than or equal to 0. Sketch the graph of the inverse. Well, again, I have this point negative 2, 0, so I can go to 0, negative 2. I have this lovely point up here of 0, 4, so I can go to 4, 0. I have this point that is negative 4, 4, so I can go to 4, negative 4. And there's my sideways parabola. State the domain and range of the inverse. They switch. So now x is greater than or equal to 0, and y is an element of all real numbers. That is for letter C. Is the inverse a function? If I do the vertical line test, it fails, so no. Number 2, again, I have this point negative 4, 0, so 0, negative 4 is down here. I have this lovely point 0, 2, so 2, 0. And my graph does something like that. There's the picture of the inverse. The domain, well, x's have to be greater than or equal to this point negative 4. Y's have to be greater than or equal to this point 0. I graphed the inverse already. The domain and the range switches, so now so x's are greater than or equal to 0, and y's are greater than or equal to negative 4. Is this a function? If I do a vertical line test on, let's not do that. If I do a vertical line test on this, it's never going to hit it more than y, so yes, more than once. So yes, this is a function. And the third one, again, I have this lovely point 2, 0, so then I would have 0, 2. I have another point here which looks like it's 6, 2. So that would give me that would give me 2, 6. And my graph would do something like that. My domain, well, my x's are greater than or equal to this x coordinate right here, so greater than or equal to 2. My y's are greater than or equal to this y coordinate here, 0. I already graphed it. My domain and range for the inverse switches. So x's are greater than or equal to 0. Y is greater than or equal to 2. Is this a function? Does this pass a vertical line test? The answer is yes. Number 3, find the inverse of the following equations by switching x and y and solving for y. Graph the original equation and the inverse in the same grid in different colors. All right, so let's graph the original. If I graph it, my y-intercept is 0. My slope is up 5, right 1, up 5, right 1, down 5, left 1, down 5, left 1. So there's my original graph. My inverse, again, I'm telling you to switch x and y. So x is equal to 5y. To get y by itself, you have to divide by 5. So I get y is equal to x over 5, which remember is y is equal to 1/5 x. Again, my y-intercept is still 0, 0, but now my slope is up 1, right 5, up 1, right 5, or down 1, left 5, down 1, left 5. There's my two lines. Letter B, again, if I go ahead and graph this first, my y-intercept is -4. My slope is -2, so down 2, right 1, down 2, right 1, down 2, right 1. Or I can go up 2, left 1, 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 up 2, left 1. Regardless, there is my line. Now I need to find the inverse. Again, I switch x and y. So x is equal to -2, x minus 4. Add 4 to both sides. By the way, this was the inverse. Okay, let's fix this. Let's add 4 to both sides. X plus 4 is equal to -2y. Divide everything by -2. And I get y is equal to negative. Now it's x over -2, so that's 1/2 x. 4 divided by a -2 is -2. So that's my inverse. My y-intercept is -2. My slope is up 1, down 1, left 2. Down 1, left 2, down 1, left 2, down 1, left 2, or up 1, right 2, up 1, right 2, up 1, right 2, up 1, right 2. There's my inverse. And again, this is my inverse function right here. Y equals -1/2 x minus 2. This last one, my y-intercept is -1. So my slope is down 1, down 1, 2, 3, left 1, 2, 3, 4, down 1, 2, 3, left 1, 2, 3, 4. Or I can go up 1, 2, 3, left 1, 2, 3, 4, up 1, 2, 3, left 1, 2, 3, 4. And there is my graph. Again, to find the inverse, I switch x and y. So x is equal to -3/4 y minus 1. Add 1 to both sides. X plus 1 is equal to -3/4 y. To get rid of a -3/4, you multiply by the reciprocal. The reciprocal of -3/4 is a -4/3. -4/3. So on the right side, I do get a y. And I distribute this through, I get -4/3 x minus 4/3. That's an ugly little problem, but that's okay. -4/3 is I'm going to go down 1/3. And from there, I'm going to go down 1, 2, 3, 4, right 1, 2, 3. Down 1, 2, 3, 4. So that's a little lower down. 1, 2, 3, 4, right 1, 2, 3. So, or I can go up 1, 2, 3, 4, left 1, 2, 3, up 1, 2, 3, 4, left 1, 2, 3, and there's my inverse. And there's my inverse equation. All right. Pendulum problems. I give you the equation. Remember, the relationship between the length of a simple pendulum and the period of the pendulum is described by the following. Use the function to predict the period of the pendulum that is 400 centimeters long. So that means P is equal to 0.2 times the square root of 400. That's my length. So then that P is equal to 0.2 times the square root of 400. Get out my handy dandy calculator. I don't have to do anything else. If I pull out my handy dandy calculator, I can just do 0.2 times the square root of 400. And I get 4. 4 seconds. How long should the pendulum be if the clockmaker wants the period to be 2 seconds? So I want my period to be 2 seconds. This is 0.2 times the square root of L. Divide both sides by 0.2. 2 divided by 0.2 is 10, is equal to the square root of L. Square both sides. So my length is equal to 100. So this is 100 centimeters. Alva notices that her grandfather clock is fast. To adjust it, she should make the pendulum wire longer or shorter. Slower means longer. The clock is going too fast. I want to slow it down, so I need to make the string longer. That is the last for the third video.